We're going to find a new number today. We've got mean, we've got median, we got your quartiles, we got the interquartile range. We're going to find a new number today called the standard deviation. Okay, it's going to be called the standard deviation. Let me just tell you in a nutshell what it is. I don't want to really read through any of this stuff because I think it gets confusing. Here's what this number will tell us: how spread out the numbers are. And here's what I mean. I don't want you guys to get the wrong feeling. Like, this is not what I mean by how spread out they are. Is how far apart I write them. Okay, that's not what I mean. All right, what do I mean by how spread out they are? Do they have a huge range? Like, if you take a look at these numbers here, are they pretty close together? The lower the standard deviation is, the closer they are together. The higher this number called the standard deviation is going to be, the more spread out they are. Okay, so do we predict here a low number or a high number for our standard deviation when I show you how to find it? A pretty low one. Okay, we're going to find it, and it's going to be pretty low here when you find it. Okay, where is this standard deviation located? Same exact screen we've been on this entire week, which is one var stats. All right, so take a minute right now. Let's plug these into our calculator. You guys know how to get to the mean and the interquartile range. Same screen. We're not jumping off that screen until Friday. Okay, so get a list going. Stat edit. Clear out whatever list you have or list. Check your list at the end. Make sure you have 20 values here because these are the weight in ounces of 20 chicks. That's cute. 2, 1, 3, 4, 2. All right, I ended up at 21. Nice. That's where I wanted to end up. Make sure you got 20 in there. Just take a look. Make sure you didn't add any extra digits on to any of them because that's going to throw everything off. All right, so we go back to stat, calculate. One var stats. We only have it in one list, so make sure, like mine right now is incorrect. I only have it in list 1, so I got to get rid of list 2 right now. Calculate. All right, here we go. Let me ask some questions here. What's the mean according to your list right now? What's the mean? Where is it? 17.
What is it?
I'm looking for the mean. 3.7. So X bar, 3.7. Interquartile range. The calculator does not give that to you, but it gives you the values on how to find it. Reminder, how do I find interquartile range? One more time here. 18. Okay, so according to our calculator here, what's the third quartile? 5, and the first quartile? 2.5. Yep, and then so my interquartile range is 2.5. All right, now we come to a new value, standard deviation. Standard deviation. Everyone ready? Standard deviation. I call it the ox. Anybody see where I'm talking about? Right here, OX, there's my standard deviation. And as we predicted, pretty small number, okay? And it says what? There are rounding directions here. Round to the nearest tenth, so 1.7. And this is how I write it, O with the subscript X, 1.7. Okay. So this number, everyone in agreement, this number is pretty low, which tells me these numbers are pretty close together. Okay. If this number were in the 20s, 30s, okay, these numbers are going to be really spread out. Okay, their range. Questions? Okay. Now, what I got to get into is there's actually 2 types of standard deviations up here, and you guys can go to the next page because it talks about it right now. Right at the top of the next page. There's 2 types of standard deviations. There's a sample standard deviation, and there's a population standard deviation. Okay, population and sample. Let me just show you on the calculator where they are. You guys just found what's called the population standard deviation. Everyone see the one above that says S. S stands for sample standard deviation. All right, there are two. When do you use which one? You use sample when it's S. Okay, it will clearly come out and say what's the sample standard deviation. If none are asked, if it doesn't get specific, we always use the population like we did in the last problem. Okay, let me go over that one last time and just focus in on this. When do I use the sample SX? When it specifically says, tell me what the sample standard deviation is. When do I use population? If it says population or if none is given. If it just says find the standard deviation, we always use the population standard deviation, okay, if it doesn't get specific. Sample, population. Sample, population. We good here? All right. All right, let's take a look now. We're given soda A and soda B. Okay, great. For the two sodas, people who drink, take a sample. Okay. I'll help you with this one, part A. Explain why standard deviation is a better measure of diversity in age than mean would be. What did we just talk about? What does standard deviation mean? What's that number? How spread out it is. Right? Everyone agree? How spread out it is. What's the mean? Well, the mean wouldn't be the middle. Means just the average here. So anybody want to try to give an explanation why would I use standard deviation here instead of mean to find the diversity in ages? Oh, here we go. Marco. Okay, there's an outlier, 40, we talked about yesterday, but why specifically standard deviation when we're talking about diversity in age? Matt? It tells you how spread out they are. Okay? Higher the standard deviation, the more diverse it's going to be. Everyone agree? Okay, the higher the standard deviation, the more spread out, the more diverse these ages are going to be. So the higher the standard deviation, the more diverse the ages. I'm going to call on you guys now. Which soda appears to have the greater diversity? Which soda appears to have the greater diversity in age? Thoughts? 21? Greater divert. What's that? I agree too. Why'd you say that, Callie? Here you go. Soda A. What's the lowest and the highest in soda A? It ranges from what two ages? 16 to 44 versus soda B, which is 30. There a 30 in there? Okay, so a lot more diverse in soda A. Which means what? What should I know about, when we find this in a second, what should I know about the standard deviation of soda A versus soda B? Soda A should be what? Greater or less than soda B? Greater, because it's more spread out. Let's find out. Use your calculator to determine the sample standard deviation here. All right, so you're going to have to go list, clear it out, do another list for soda B. Round it to the nearest tenth, so you're going to have to do a list for each. Remember, when you go to calculate it, you only calculate it one list apiece. You should never have two different lists in there. We'll see if our prediction was correct. That soda A should have had the higher standard deviation because their ages were more spread out. Remember, we're doing sample here, sample standard deviation, specifically as sample. So make sure you're looking at the sample one, not the population. Because something happened where it got deleted. There is, yeah. You just got to reset the memory, but you can get L2 back. So when that's done resetting, you should have all your lists back. Just make sure maybe you press delete instead of clear. Because if you press delete, now go back to your list. You should have it in there now. Boom. All right, here you go. Anybody have soda A ready to go? Sample standard deviation for soda A. 18, sample standard deviation for soda A. 9.1. Here's how I'm going to write it too. S for sample, lowercase a, 9.1. Yep, 9.1. And if you're way off from 9.1, maybe you type something wrong. And see, that's like the calculators are awesome. This whole unit's on the calculator. That's awesome. Does all the work for you. But you type in one change in number, everything gets thrown off, unfortunately. And then what about the sample for soda B? Sample standard deviation for soda B. Here we go, 2. 4.1. So was our prediction correct? Yeah. Soda A had more diversity, spread out more. That's why it had the higher standard deviation. All right, so we okay with standard deviation? The higher it is, the more spread out the scores are. Lower it is, the more packed in. What do you got, Kate?
So what's the difference between sample and population?
Okay, sample, good question. Here you go. Let me try to get this whole class example. Let's say I went around and, I need something to test. I don't know. I was going to say ages, but most of you guys are around the same age anyway. Shoe size. Okay, shoe size. I get everyone's shoe size, and I do the standard deviation. That would be population, because I got everybody. Let's say I just pick the first 7 that come through the door in class today, and nobody else. That's just a sample of everyone. So I would take the sample standard deviation over the population. Population is when you can get everybody. Sample is just, it's too big. I need a portion of what you're trying to test. Okay, good question, Emma.
So would this sample be like the basketball team thing?
Correct, yes. Mm-hmm. Yep. Good questions, guys. Anything else? So standard deviation, we're all set. You guys have the practice for tonight, which doesn't look too bad. 10 questions, most of them are multiple choice, and you're going to be plugging them into your calculator. All right, you know where we're going now. Getting hardcore. Let's go. $27. Get those calculators ready. 4 weeks from yesterday, by the way. 4 weeks from yesterday. And it's good news, probably not good news for you, but good news for me because we end classes on Monday and the test is the following day. So we don't have a big gap where we don't see each other or maybe not studying for anything there. I think it's in the afternoon. Yeah, so that's perfect for us because I'll be here all morning doing a hardcore review session. I'm sure also that Saturday before I'll come in, and if anybody wants to review, we can review as well. I usually have a couple Saturday sessions for both, well, usually for geometry. I haven't done the algebra before, but you guys can come in the Saturday before. We have Monday after school, and we'll have Tuesday in the morning. Still debating or not whether to come in Monday night. We'll see about that if I really want to torture myself that much. All right, here we go. We're going to graph x squared minus 4x minus 1. Before we do anything, what's this graph called when I throw it on the graph? It's called a parabola. Good. Is it going to open up or down? It's going to open up perfectly. You need to show me a chart of values. So let's go back to the days when we liked each other. Anybody remember how to get the first value? And this kind of answers the question down below. Find the what first? Axis of symmetry. Yep, that'll be my middle value in my table. Anybody remember the formula? Axis of symmetry. Keep it rolling, Tom. Negative b over 2a. Yep. All right, need somebody to plug in for b and a for me. Here you go, 20. What are my b and a values? -4. What happens when I plug it in? 4 over 2 times. What's your a value? 1. Axis of symmetry should be x equals 2. All right, so make sure you show your xy table now. 2's in the middle. And what have I always required of you guys now? 3 above, 3 below. Yep, 3 above, 3 below. And let your calculator do all the work now. Okay, 3 above, 3 below. Let your calculator do the work. Let's get going. Shouldn't see some blank pages here. Let's get going. And you should notice your y value is repeating, which is perfect. Smooth curve, no straight lines. This is awful. Question for you. Did I give you a certain x values to graph from? Or did you find them yourself? Did I say graph from this x value to this x value? No, I did not give you a domain to graph over. That I'm asking that because you should not just be connecting them. Unfortunately, that would be a point off if you just connected them and that's it. All right, it's got to have arrows on there. Oh, look at that beaut. Okay. Perfect. 2 points. What, Marco? Go ahead, criticize it. Yeah, good. Because you'd be drinking through a straw. Go ahead. Or eating through a straw, excuse me. Okay, here we go. Good question. The question, in case you didn't hear it, was what's the deal with pen, pencil, etc. Pen on everything, yes, except for graphs. So in this one, everyone, hey, focus in. On this one in particular, this can be in pencil. That's in pen. Okay? The only thing that can be in pencil or any graphs, like histograms, you do any box and whiskers, parabola graphs, inequality graphs, they can be done in pencil. But if you do work on the bottom or around it, it's got to be in pen. And that includes everything. Everything's in pen. Okay? Yep. With the answers on it? Yep. Okay, part 1, you'll get a bubble sheet, which has to be done in pen as well. But parts 2, 3, and 4 is what you're looking at right now in front of you. You know, a page dedicated to every question. You have 3 hours to take it. You can leave if you're satisfied after 2. But you have 3 hours to take it. And we'll talk more about that as we come across, when we get closer to it. Yep. Okay, but that's the pen pencil deal. All right, all good? All right, you guys got to buckle up for this one. This is no joke, this next one. This might be the toughest one we've done together and I've seen in a while. Number 35. Buckle up. Whew. Okay, first thing. No matter how tough you think it is, we don't leave anything blank on this. You do not leave anything blank. All right, you could get partial credit, you never know. All right, get partial credit. When you leave it blank, you know you're getting a 0. Okay, don't leave anything blank, no matter how tough you think it is. At least write down something. All right, we got a lot going on here. We got an airplane, great. Leaves New York City to LA, great. I don't care about that. As it climbs, the plane gradually increases its speed until it reaches a cruising altitude. So what I'm going to do right now is I'm going to just draw myself a little picture about what's happening. All right, so the plane on the ground, I'll call it point A. All right, at point A, it starts rising, right? Then it hits the plane increases its speed until it reaches a cruising altitude, which maintains it a constant speed. So let's say right here, it reaches that cruising altitude. What type of line should I be drawing in now for the cruising altitude? They're all straight. Horizontal, thank you. Straight, you kids. They're all straight. All right, and then that's really about constant speed, stays at the cruising altitude for so many minutes, we'll get to in a second. Determine the speed of the plane at the cruising altitude in miles per minute. All right, we can do this. So it ends, I'm just going to say, here you go, it's 6. Rises, cruising altitude, here we go. Can anybody help me get a little bit more detailed with my diagram? Can anybody tell me how many miles and how many minutes just read the problem. No calculator use here, just read the problem. How many minutes and miles did it take to go from A to B to reach that cruising altitude? It's right in there. Right in there. Go ahead, Caitlin.
192 miles.
Okay, so at point B right now, everyone. At point B, it's gone how many miles? 192 miles. And how many minutes? 32. Is everyone all right there? 32 minutes. So at point B, it's gone 192 miles, and it's been in the air for 32 minutes. Can anybody tell me what's happening at point C? At point C, how long has it been in the air and for how many miles? Again, right on in the problem. I'm not doing any calculations yet. It's right in the problem. At point C now, how many miles and how many minutes? Carol, what do you got for me? 762 miles it's gone. In how many minutes? 92 minutes. Got it. Okay, everyone good? We okay with that setup right there? Because that's going to help us a ton answering these next 3 questions. All right. Determine the plane speed at cruising altitude. Name the points that represent the cruising altitude. B to C, and you got to put it in miles over minutes. Miles over minutes. So from B to C, now I'm going to start asking individual people. From B to C, how many miles did it go? How many miles did it go from B to C? This is why I set up this nice diagram here. How many miles did it go from B to C? Here you go, 29. How many miles did it go? How'd you get it? So what two numbers are you subtracting, Matt? Okay, 762 minus 192. What did it give you, Matt? 570 miles per minute. How many minutes has it been in the air from B to C? How many minutes has it been in the air? 15. How many minutes has it been in the air? 60 minutes. 570 miles in 60 minutes. Let's keep reducing that for me now. 570 over 60, because I need it per minute out of 1 minute. So how many miles is it going every minute? 30. How many miles per minute? Okay, there you go. 9.5 miles every minute. Okay? At the cruising altitude anyway. All right, at the cruising altitude, every minute it's going 9.5 miles. You guys are right there, because we're going to get a little tougher now in the next one. All good? Anything, guys, go. All right. We're going to write an equation, so something with an equal sign represents the number of miles the plane has flown, y. So we're going to call y the number of miles it's flown during x minutes at cruising altitude. Cruising out. What did we just find out about cruising altitude? How fast is it going? 9.5 miles per. Okay, what are we calling the minutes now? Read the problem. What are we calling the minutes now, Jack? X. So 9.5 times X, the number of minutes, will equal the number of miles, which we're calling Y. Y equals 9.5 miles per minute. All right, minutes, miles. Any issues so far? Going. Finally, he's going to maintain that 9.5 miles per minute. Determine the total number of miles, the total from the beginning to the end in 2 hours. How many miles did it go in 2 hours? Beginning to end. In 2 hours. All right, well, everything's been in minutes here, right? Everything's been in minutes. 2 hours in minutes first. Need some help. 22, 2 hours in minutes. 120, yep. All right, let's go back. Whoop. How many miles did it go in 32 minutes? 100 and? So I got to count that. So I have 192 miles already. Again, that's for 32 minutes. Then it reaches that cruising altitude. How many minutes are still left for me to calculate? I got 32 minutes out of 120. How many minutes are still left? 10. How many minutes are still left? Not here? Yeah, you should be. I'll run the class. I have 88 minutes left. 88 minutes left, and it's going where now? 88 minutes left. Everyone agree? And we already know what this is, right? What's the miles per minute here? 9.5. Yes, 9.5 from here. So what should I add on here? Carol, how many minutes are left? 88 minutes are left. How can I find how many miles I went in those 88 minutes? You guys did the hard work above. You did the hard work above. How can you find how many miles you're going to go in 88 minutes at that cruising altitude? Help, help. 24. You're at the cruising altitude. What did we find? How many miles per minute do you go at the cruising altitude? How many miles per minute do you go at the cruising altitude? Every minute, right? Well, how many minutes do I still have to go? So what should I do with the 9.5 and the 88? All right, here we go. How many total miles am I going here in 2 hours then? 29? Did anybody also want to do this instead? Just say, look, there's 762 here. They do 120 minus 92 and then multiply that by 9.5. You can do that as well. Fiona.
Why can't you do like when we got for the first question, we figured out that it went 570 miles in 60 minutes. So why can't we just multiply that by 2?
Multiply it by what? Because here's the thing though, that whole 2 hours they didn't go. If the question was 2 hours at the cruising altitude, you'd be correct. But here it's 2 hours. You see right here, I got to include that part as well into my 2 hours. This right here is the cruising altitude from B to C. They went 570 in 60 minutes at that speed.
Isn't that what it's asking?
This is asking total here, I believe. If it maintains its speed what it's saying is if it maintains its speed at cruising altitude, just keeps going at cruising altitude. How many total miles will it be after 2 hours? It's just not asking 2 hours at cruising altitude. See what I mean? You have to also include the time for getting off the ground to getting there. Okay? Emma, you had a question?
No.
Anything else here? Again, tough one, I know. We may see one that's that tough. All right, let's get out of it. We're done with it now. Let's go back to multiple choice. 13. Oh, just finished this, huh? In a sequence, the first term is 4, common difference is 3. What's the fifth term? All right, right away. Hey, common difference. This tells me it's what type of sequence? 23. What type of sequence had a common difference? Arithmetic. And in an arithmetic, did I add or multiply? In an arithmetic, add or multiply. 23 again, add or multiply? Add. There you go. So you guys know the first term's 4. Go ahead and find the fifth term. Now that you know it's arithmetic and you're adding. All right, what did you have? Here you go, 28. 4, how'd you get 4? What's the second term? 7, right? What's the third term? 10. Fourth term? 13. Fifth term? Good? Everyone else all right? Just finding, adding them up. We're all good? Okay, 14. Here you go. 14. This one's a little bit tougher. You're going to have to write down a couple notes here for me. Okay, they give me this one right here. Anybody know what type of equation that's called? Begins with an E. Exponential equation. Yep, this is an exponential. All right, number of cells, great. Which one of these is about the same as this one right here? That's what it's asking. Okay, which one of these is about the same as that one right there? All right, we need a little exponent review, right? You guys do exponents this year? I should ask that first. Exponents? Or let me guess, the answer usually is we grazed over it a little bit. Okay, do you remember this rule? When I raise an exponent to another one, so if I have a to the b If I raise an exponent to another one, you remember what the rule was? What to do with those two exponents? Multiply them, yes. So this is really a to the bx, okay? I don't know if anybody remembers that rule, but we'll put it in your memory bank there. When I raise an exponent to another one, I multiply it. Here's why I'm showing you this. Look at the equation they gave me. What's happening between the 24 and the t? Multiplication. So can I break that up? Tell me another way I could rewrite this. 1.029 raised to the, break it up, raised to the 24th, all raised to the t. Everyone in their calculator, go ahead. What is 1.029 raised to the 24th? And you should see a similar multiple choice up there. And again, it says approximate, not exactly. So which one up here, when you raise 1.029 to the 24th, is about the same equation up here now? 1? 3, yep. Okay, so again, when you see them being multiplied, you can break them up separately, because that's what the rule tells us. I can break them up separately. All right. The other way to do it is plug that into your calculator, y equals, go to a table, and then plug each one of these into a separate y equals and see what their tables look like. They should be about the same. What's the next one? Do we have time? Yeah, we have time to do this last one here. 15. Okay, big table here, age and support for a candidate, the results of the poll, yep. What percent of the 20 to 40 age group are for the candidate? Percent, so I know it's something out of something, just like your test scores. Anybody want to tell me, using the table, how many are for a candidate in the 21 to 40 range? How many are for a candidate in that age range only? 6. Just read in the table, how many are for it? 30. Now, here's where I'm a little concerned. What would it be out of? Because I know most of you would just try to add up all those numbers in the table. But it's what? What percent of the 21 to 40 age group? So this are the only 3 numbers I'm looking at for the out of. Because it's a percent of this age group. So how many total are in that age group to put over 30 or under 30? 17? What is it? 30. I'm just looking for the bottom number here. I know there's 3, but there's 34, 12 against. I need to know how many people there are total. 50. So 30 out of 50. Everyone see why 50 and not adding up the whole table? So this ends up being a percent of, finish it strong, 11? 60%. Yep. Okay, you guys know what's coming up tomorrow. We'll go over the homework, and then you'll take the quiz. Last 2 exams. Well, it depends, I guess, on who you are and what you do to prepare.